I just wanted to let you know today's lecture is going to be a little bit funky because I need to be able to show you guys model kits, draw on a whiteboard, now called the clipboard, and also kind of show you some manipulations and kind of talk to you directly. So the best way that I could figure out how to do this was just with a clipboard and a marker. So we will give this a try. As always, if you have questions, please contact me. One of the first things to review is this idea that if I have a carbon that's bonded to 4 different things, like I do here, that's called an asymmetric carbon. And many of these things lead to something which is called chirality or handedness. So one of the things that scientists have to be able to do is draw this thing on a flat piece of paper that in some way communicates the 3-dimensionality of the situation. So I just have one enantiomer right here, right? And so we're going to see how to draw this. Then I'm going to draw its enantiomer using a couple of different projection methods, and then we'll kind of start to build actual molecules that are a little bit more complex. So the most common way that the 3-dimensionality of an asymmetric carbon is to, first of all, just draw a T that represents all the 4 groups. And one of the really important things about these Fischer projections is that you recognize that anything that is on the vertical, right? And so this obviously is the vertical line right here. That is always going away from you, right? And so what you can kind of see is the way I'm holding this right now, that both that red sphere and the white sphere are both kind of going away from you. So I'm going to put that in the Fischer projection, and then we'll start to talk about the horizontal or the sideways line and what that thing is showing us in terms of this way of representing 3-dimensional compounds. So now I've written in the red sphere on the top and the white sphere on the bottom, and keep in mind anything in a Fischer projection is projecting away from you. So what I could have done, if I imagine that center carbon right there, I'm going to draw like some wedges and dashes that we've also talked about to kind of give you a little bit more of a realistic perspective of the way that this thing is being represented. So one thing you hopefully will remember from previous classes is anywhere that there's a dashed wedge, that's a dash, that always means that it's projecting into the kind of away from you, I guess we'll say. Right? And so, believe it or not, just the fact that I know that's a Fischer projection, I know that anything that's written on the vertical is projecting away from me. And one of the things that you'll notice is if I kind of hold up the model here, if I can orient it correctly, there we go, you'll notice that that red and the white sphere are kind of projected like that. Well, you can look at this kind of horizontal position. You'll notice that if I position 2 groups going backwards, that both of the groups that I see that are kind of in front of the plane are both projecting forward. And so here we can see I've included the horizontal position here. And what you'll notice is that if the red and the white are projected away from us, you'll notice this blue and the green are both reaching out towards you, right? And so I've tried to indicate that in 2 different ways. One is on the Fischer projection, and then the other one actually shows you the solid wedge of this perspective drawing right here. And so what you see is that something that, even though it's written on a flat piece of paper, really represents 3-dimensional space. And as I said, I really struggled with this when I was going through. Just to kind of, even just to take something that I had in my hand and to write it on a piece of paper was pretty difficult. So let me show you a couple of just kind of cool tricks about looking at Fischer projections that kind of make our lives a little bit easier. And then we'll start to kind of build some, like I said, some more complex systems. So keep in mind, anytime I make a mirror image of something which is chiral, or in this case, a single asymmetric carbon, what we end up with is, first of all, a mirror image, right? And so you can pretty obviously see, even with this Fischer projection, that I've got a mirror image here. I basically just took a mirror plane and reflected it across. And so this, believe it or not, is the Fischer projection of the enantiomer. It turns out the rules for Fischer projections are such that if you look at any Fischer projection and you take that Fischer projection and it looks like you've reflected everything in a mirror, turns out that that thing is an enantiomer. if it looks like, if it's a more complex system than this, which we'll get to in just a second, if anything is not a perfect mirror image, cannot be an enantiomer, right? So an enantiomer is that thing that is the mirror image that is a non-superimposable image of the other thing, right? And so what you need in order to use Fischer projections is, first of all, at least one carbon that is asymmetric, bonded to 4 different things. And then what you know about that Fischer projection is if you just reflect it in a mirror plane, you end up with the enantiomer. And I should tell you, there's all kinds of different rules, and I think your book goes through a little bit, or at least the PDF that I gave you guys goes through the rules for this thing. We're not going to concentrate on those too much. I'm going to try to just kind of keep things a little bit more simple than that. And so what we're going to do next is we're going to build an actual organic compound. And we're going to actually take the Fischer projection, and what we're going to do is we're going to try to manipulate it, and I'll show you 2 other ways that you can represent things in 3-dimensional space. So over here in my left hand, what I've built is something that has just one asymmetric carbon. You can see it right there, smack dab in the middle. This guy. Each one of these groups is a different group that is bonded to, right? And so let's say this green, let's say that's a chlorine. This guy over here, that's going to be an alcohol or an OH group. This guy up here is a carboxylic acid, and this guy down here is just a simple methyl group, right? Just a normal old carbon. So the thing about Fischer projections is the only thing that we really care about drawing correctly is the actual asymmetric carbon, right? And the rule is not only do anything I put on the vertical is automatically going away from me, but it also is a rule of Fischer projections that you have to show like what's called the carbon backbone in that up and down fashion. So in other words, because of the rules of Fischer projections, what I have to do is kind of hold this thing kind of like this, right? And you notice that in each case, that carbon bond, wow, this is hard to do, that carbon bond, you'll notice it kind of forms almost a C. So that C has to be faced away from you, right? It has to look like this, right? And so you can see that we're kind of like looking smack dab at that C. So when we do that, anything that we put on the vertical is obviously going away from us. And when I hold it like that, you'll notice that we've got this OH group on one particular side and that chlorine group on the other side. So let me draw what that should look like as a Fischer projection, and then we'll play some more games. So here's the Fischer projection of that one chiral compound. And if I can hold it up properly, that's what is being shown. Right? You can see that C on the vertical there, kind of twisted a little bit, but you can also see that OH group is matching and that green Cl group is matching on that other side right there. So just remember that anything written on the vertical is automatically going away from you, and anything on the sides is being held towards you. So I always had an aunt that I just couldn't stand seeing, and every time I saw her, she would always have her arms out like this, right? And so when I look at these Fischer projections, I always imagine that my aunt is coming at me with her arms, right? So anything that is on the horizontal is like, I want to hug you and squeeze you, right? Whereas anything that is on the vertical is kind of like arching away from me, right? Because that's what my aunt used to do. She'd reach for me like this. Oh, please, give me some of that, you know? So Fischer projections are kind of similar. So what I'm going to do is I'm going to take this and I'm going to show you, first of all, that projection formula that we saw previously in terms of wedges and dashes. And then I'm going to take that projection formula and I'm going to twist it and try to put a bunch of atoms in the plane. And what you'll hopefully be able to see when I do that is exactly what this thing looks like, is what's called a realistic three-dimensional perspective drawing. Oops, I did forget one thing. One of the things you'll notice is the only thing that I didn't draw out were the things that weren't asymmetric carbons, right? So that carboxylic acid, even though I know that it's got like a certain geometry, we don't really care about it because it's not asymmetric. It doesn't have any like weird three-dimensionality in terms of chirality. Same goes for this guy right here. So that's kind of one of the things that you'll often see to kind of simplify your Fischer projections, is that only the asymmetric carbons are kind of drawn out like this. Oh, and by the way, obviously there's a carbon in the middle. So anyway, now we can draw another perspective. Okay, so there's my ant, right? My ant has an OH in one hand, a Cl in the other. She's reaching out at you. And then her head is the carboxyl group, and her feet, we'll say, are the CH3 group, okay? And so what I'm going to do now is I'm going to take this thing, and I'm going to rotate it in 3 dimensions like this, right? So what I'm going to do is let me take I'll hold it exactly like it's written, or as best I can, right? And so here is our molecule, right? That's projecting, those horizontal things are projecting towards you. And what I'm going to do now is I'm going to rotate this thing very slightly in 90 degrees. And when I do that, you'll notice that now what I have, if you kind of look at this thing, is I've got 2 groups that are now in the plane, right? These 2 groups are now in the plane. This guy is that methyl group, you can almost not even see, right? It's kind of stabbing me in the eye. It's going away from you guys. And this Cl group is coming towards you. So let me kind of draw that situation. So all I did is I just took this thing that used to look like this, right? Which is kind of the Fischer projection way of looking at everything. And I rotated it just a little bit such that I could get just these 2 bonds in the plane of the paper, which kind of caused these guys to become wedges and dashes. So let's kind of see what that looks like. Okay, so that was no problem, right? That's just straight from the Fischer projection. But it turns out that rotation I just showed you turned that sucker into this, right? Where I said that carboxyl group bond was going to be in the plane along with the Cl. And the cause of that rotation caused this OH group to still be pointing towards us, that CH3 group to still be pointing backwards, but now I put these 2 in the same plane. And this is what's called a realistic 3-dimensional projection. So a realistic 3D projection right there. So it would still be the case that if I took this thing and I reflected it in a mirror plane, that I would end up with the enantiomer, and I could certainly do that. The really confusing thing is that I didn't have to rotate this like I did. I could have done all kinds of things. I could have flipped it upside down and rotated it to the left, to the right. I could have altered the angle that I rotated it. But those are all things that I really used to struggle with, and the only real way to play around with that is with a model kit. And obviously we don't all have model kits, so it's going to be kind of tough to see. So I'm going to do my best to find some programs that maybe will help you guys kind of manipulate some of these structures. I'm not confident that I'm going to find them, but I at least wanted to kind of show you, I don't want to say a simple, but an example of how to take something in a Fischer projection and turn it into a realistic 3D projection. What I would practice with is see if you can at least practice in your mind to see if you can convert this compound into something like this. And just for purposes of, kind of expanding your mind, I'm going to just show some different ways that this guy could be realistically drawn as well. So the first one I chose to show you here is what I did I did a 180-degree rotation around what's called a vertical axis. And you'll notice that what has happened when I did that, first of all, the chlorine goes on the other side, right? So there's the chlorine. But the fact is because I rotated this thing 180 degrees, anything that was poking out at me is now projected behind the paper, right? And so my solid wedge became a dash. My dashed wedge became a solid, right? And so that's an example of me doing a 180-degree rotation like that. Just for fun, maybe we can take a look at what I did there, right? And so here is the perspective we were looking at before, or is it flipped? Oop, I already flipped it. But anyway, oh my god, this is so hard to do, right? And so you can see that when I flip this thing 180 degrees, suddenly those groups that used to be coming out at me, right, are all kind of switching to going behind the plane now. So here's a much tougher one than 180 degree rotation, right? That I could kind of see that, well, okay, the CL goes to the other side and my wedges and dashes flip. Well, what I've done here is I've rotated in this direction 60 degrees. And so essentially what I've done is I took this OH group that used to be poking out at us, and now I put it in the plane of the paper, right? And one of the things that you'll notice about that is everything kind of has to maintain its relative orientation. So the fact that I rotated that OH now into the plane of the board, that actually takes a CL and pushes it out, right? So you'll notice that as I drew it down here, that CL is actually poking out. That CH3 group, though, it really is still projecting backwards. It just kind of would move its way to the other side, right? And so this is something that spatial orientation that artists really seem to be able to grasp really well, something that I really had to play around with a model kit to try to understand. So try to kind of do some of these manipulations, see if you can make any sense out of these. Before you go, though, I did want to show you a compound that has 2 chiral carbons, and just to kind of show you some tricks there, right? So I made what looks like a total mess here. So what we're going to do is we're going to try to rotate some bonds until we get something that I can draw in a Fischer projection, right? And so what you'll notice is that I've got kind of like a zigzag, and I know in a Fischer projection that I have to keep all of those carbons on the vertical and kind of going away from me. So what I'm going to do is I'm going to rotate it so that I can then see the C, right? You can see, so those black carbons make a C, and I know that C has to be projected like that on the vertical, right? And you notice that my ant still has her hands being held out, right? So anything that's on the vertical like that, right? We notice an OH group over here, a CL group right here. We notice another CL group right there, and then an H over there. So let's take this thing, and I'll show you the realistic, I'm sorry, not the realistic, I'll show you the Fischer projection, and then we'll draw a realistic perspective from there. Okay, so I've got this thing, right? I've got it arching away from me, right? It's arching away from me. And I've got the beginnings of my Fischer projection. You'll notice that now I have 2 asymmetric carbons. I've got 2 carbons bonded to 4 different things. I put my my carboxylic acid group at the top, my methyl group at the bottom, because those aren't asymmetric, so I don't really care about showing those as little t's. So let's keep track of what my groups are doing right here. So we'll have to refer back to the model kit. So that very first carbon, the one just one away from the carboxylic acid group, you'll notice that I've got a OH group on this side and a CL group over on that side. So drawn correctly, that particular carbon, you'll notice that's a CL, sorry about that, right? So hopefully you can recognize that CL over there, OH group over on the right, and that is in fact the case if you look at this, right? So from your perspective, that OH is over on the right, that CL is on the left. And then what is the relative orientation of that H and other chlorine on the other one? Well, I can see that chlorine is on the opposite side of the other chlorine, right? And so I'm going to draw that one on the right with an H on the left and my Fischer projection. Right? So that molecule, and feel free to go back and forth if you can make any sense out of this, looks like that in a Fischer projection. So let's now draw this thing as a realistic perspective, and we'll probably stop there. Okay, so hopefully nobody will argue about that guy right there. Keep in mind anything on the vertical is going away from you. Anything on the horizontal is going towards you. So it's probably pretty straightforward to go from there to this guy. But now what I'm going to do is I'm going to take this whole thing and I'm going to rotate it like this, right? I could have rotated it anyway. I just kind of like to rotate like that, right? And so hopefully you'll see that when I take this thing and I rotate it that direction, that CL group that used to be poking me in the eyeball is now going to be a dashed wedge that's going out behind. That other OH, though, that's, are still gonna be poking me in the eyeball, right? Because I'm rotating away from it, it's still gonna be poking out at me here. So let's see what that sucker looks like. Okay, so there's the realistic perspective right there. You'll notice a couple of things. Number one, you'll notice that C is still there, right? That thing that used to be arching away from you. Now you can kind of see it written into the plane of the paper. Anything on this side becomes a dashed. Anything on that side stays a wedge, right? And obviously I could have taken this whole entire thing and rotated it all the way the other way, and the opposite would be true. Pretty soon we're going to quit. I just wanted to show you one of the greatest things about Fischer projections, and one of the reasons that they're, I don't know, sometimes like a lot easier to look at than looking at something like this with all kinds of wedges and dashes, because it turns out you'd be able to pick out an enantiomer from a list pretty easily, because I know that every one of the asymmetric groups doesn't matter. I'm just looking for the one where all of these guys switch, right? And so I'll just kind of show the enantiomer and then we'll quit. So there we've got the enantiomer of all the, well, these are all the same compound, but that is the enantiomer of the original compound. And what you'll notice is that everywhere that I had an OH on the right before, now I have an OH on the left. Everywhere that I had a Cl on the right before, I now have a Cl on the left, right? And so these, like, they're pretty easy to look at and tell that those guys are enantiomers. So anyway, see what you can do to make sense out of any of this. And if it's a total mess, I totally understand, and you just have to communicate that to me.